In this topic, we will talk about the use of VPC in data centers as well as why we prefer to avoid it. With Cisco Virtual Port-Channel, two Cisco Nexus switches can appear as one logical switch to the downstream device. When VPC multi-chassis link aggregation is implemented, the spanning tree protocol or STP does not block any links. In turn, this results in a significant increase in network bandwidth and availability. Let's see the advantages of VPC first. VPC increases network availability by allowing multiple paths between devices without relying on spanning tree to block the connections. By aggregating multiple links into single logical link, VPC increases network bandwidth. By combining multiple switch into single switch, VPC simplifies the network design. Network connectivity can be maintained while servers and other network devices are moved between the switches. Here are some of the disadvantages of using VPC in the data center networks. Configuration of VPC can be complex and require a deep understanding of technology behind it in order to have it configured correctly. VPC is only compatible with Nexus switches and not compatible with other Cisco or third-party switches. It is important to configure VLAN consistency on both peers. Subnet overlapping is not supported on VPC peer switches. VPC can create layer 2 loops if not configured correctly. There are scalability issues associated with VPC, so larger networks may require multiple pair of switches to accommodate the end host. It is necessary to implement STP when pair of switches are introduced in the layer 2 network in order to prevent loop between the switch pair. With STP, all of the disadvantages discussed in the STP section comes to play.